Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Unlock the full potential of your AI workloads with a seamless and composable data infrastructure. Bruin is an open-source framework that streamlines integration from the command line, allowing you to focus on what matters most, building intelligent systems. Write Python code for your business logic and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. With native support for ML and AI workloads, Bruin empowers data teams to deliver faster, more reliable, and scalable AI solutions. Harness Bruin's connectors for hundreds of platforms, including popular machine learning frameworks like TensorFlow and PyTorch. Build end-to-end AI workflows that integrate seamlessly with your existing tech stack. Join the ranks of forward-thinking organizations that are revolutionizing their data engineering with Bruin. Get started today at aiengineeringpodcast.com/Bruin, and for dbt Cloud customers, enjoy a $1,000 credit to migrate to Bruin Cloud. Your host is Tobias Macy, and today I'm interviewing Guillaume de Saint Marc about the complexities and opportunities of scaling multi-agent systems. So, Guillaume, can you start by introducing yourself?
Sure. Hey, hi, Tobias, and thanks for having me. So I'm actually the Vice President of Engineering for a team at Cisco called Outshift. And Outshift is our internal incubation team, internal incubator. So our mission is to basically project ourselves a little bit ahead of the curve and explore areas which could be very, very high potential for Cisco, very, very high potential for our customers and partners, typically with technology which is barely mature, sometimes not even fully proven. Definitely where market and product are not shaped yet. So basically, we are equipped as a group to work on highly risky and very ambiguous topics, but which could, of course, be a super high reward for the company and for our customers. And we spend most of our time failing on what we do. This is the name of the game. Like, we explore things which are not materializing. But, once in a while, we stumble on something which turns out to be really, really important for us and for the future of business. So that's what I do. And my team consists primarily of software developers, software engineers, and platform engineers, and a stronger AI ML team as well. So that's us. And I have, a bunch of distinguished engineers and principal engineers who spend their time finding patterns and pushing the boundaries. And that's a very fun and a wonderful team to work with, I have to say.
And do you remember how you first got started working in the ML and AI space?
Yeah, so I've been. It turns out that, gosh, it's a long time, but now for the past 25 years, I've only done this type of job across the different companies I've been at, starting in the media area and then moving to Cisco, which is much more of a horizontal platform and infrastructure type of company. But so I've always been working on what's next. And what is going to come and disrupt us? What are the new things which are emerging, which we need to get on top of, and how we can disrupt ourselves before someone else is doing this. And so AI ML topic really came progressively. And for me, one of the key moments I remember is 2012. This is really where we really started to realize that something called deep learning was happening and was going to be more important than just, like the also important, more classic machine learning that we were starting to productize at the time, and we had looked in the team for a little while. But yes, so 2012 was a big moment for me and for the team, and we did quite a lot of work on machine vision at the time. And this was in the context of video, and then with Cisco, IoT, and there's a lot of products we have today in the Meraki product portfolio, for instance, around machine vision. So it started like this. And interestingly, in 2015 until 2018 with part of my team, we did a lot of work on something which we called, we were obsessed about reasoning engines. So the ability to combine basically some classic, some sub-symbolic machine learning, deep learning, typically machine vision, with some ability to reason. So not just like extract characteristic and objects from a situation, a picture, and then start reasoning about what is it exactly happening here. Of course, this was pre-LLM era. So, but it was already an attempt at combining symbolic reasoning with deep learning at the time. And I think this is still a promising model for the future, to combine symbolic reasoning, deterministic reasoning with the power of transformers and LLMs and generative AI as we see today. So we were already sort of had a lot of intuition in this direction. And of course, over the past few years, there's been a massive amount of work in our team to embrace generative AI, especially when we realized that this was going to change pretty much everything for us in our domain and for our customers.
And one of the key areas of focus for the work that you're doing at Outshift, based on some of the material that I was reviewing while I prepared, is this idea of multi-agent systems, where we very rapidly evolved from the initial bout of large language models, with ChatGPT being the standout exemplar of these chat systems, and then realizing that we could actually use them for doing more than just be a fancy party trick of being able to be a conversational interface, and have moved into this realm of agentic use cases where we discovered how to wire in different tool calls into these LLMs and then empower them to be able to make decisions about which tools to call and with what parameters. And now, as we continue pushing on that, we're figuring out how do we actually orchestrate these across multiple different agents. And I'm just wondering if you can give your definition and overview about how you think about what constitutes a multi-agent system.
Right, and this is, I mean, what you said is important. I'll just emphasize it for a second, and then answer your specific question. I think when everyone, of course, remember today, I hope so, the ChatGPT moment, and when we realized the depth and the reach of the transformers. And it was like this fascinating way to generate natural language and interact in natural language with knowledge. And that was like the obvious massive use case. And we all saw this and we're like, oh, this is massive and this is so cool. And it was a bit magic also. We are getting used to it. So the magic is fading away a bit, but it's still incredible how the machine can generate, this very human type of fluid language in the interaction. But the thing which and this is not an invention, it's really a discovery, right? Like we collectively, the world discovered how another emerging behavior, emerging characteristic of these large language models, which is their ability to do some level of reasoning. And I think this has been less understood at the moment. We started to talk about it, a few months after, like, again, ChatGPT moment. And, I would say even a well-known Chinese companies has been actually doing a better job at surprising the world with this ability to reason, right? Because suddenly a smaller model was trading, intense training for more inference cycles, and taking a problem and showing how an LLM is capable of looking at a problem, and instead of trying to solve everything in one hop, in one inference, just take your time, chop it into sub problems, look at each problem, resolve, reassemble. These are the foundation of how humans are reasoning. Like if we go back to a well-known guy called Descartes, the French mathematician and philosopher, it was like, you can resolve everything by decomposing a problem into smaller problems, solve them, reassemble, right? So that's really this, right? And when we saw that, we thought that there was something bigger at stake. And this ability to do reasoning was leading to combining the ability to generate content, access knowledge, but also do reasoning. We started to see the pattern for a credible way for agents to achieve goal-oriented missions or tasks, and that was very exciting. And at the same time, we saw immediately the problem, which was, well, this is great. This is definitely something which is going to be exciting, but wait, we are stepping into a completely new moment or era for computer science, which is we're going to start really combining probabilistic and deterministic in a way which we had never done before. And how can we do all this software with this stochastic probabilistic nature, and how can we apply this to enterprise and IT and problems which so far have been using primarily deterministic software? And so we started to realize that agents will be, of course, something very important. That was, I would say, on the course of 2023 that we realized this. And we saw that one thing which is going to be key is that the agents will have to be specialized, because if they are not specialized, it's going to be very difficult for enterprise to trust them. If I take the comparison, and I'll do this a few times, with humans, and this is obviously a very imperfect comparison. So I don't think agents are humans, right? AI agents are humans, but they have attributes in a way. It's obvious that if I tell you, hey, Tobias, there's this great guy, you should hire him. He's the best at coding and can do all your engineering. Oh, he's also a wonderful marketing guy, and he's great at HR, and he can do your finance. You're going to probably look at me and say, Guillaume, this is too good to be true. I can't trust someone like this. It's the same for agents, right? Agents will be trusted by enterprise if they are really specialized. And so that's why we had the intuition very early that multi-agent systems, so the ability for agents to collaborate to achieve a bigger goal or mission, will be really something important, because each individual agents will be trusted for what they are good at. And this also replicates something which we see with humans, which is we're good when we work as a team. And there's many, many ways to create a multi-agent system. But so basically, a multi-agent system is a system where you have multiple agents collaborating to achieve a task or to achieve a goal or a mission. And this can be, by the way, a sort of an infinite game. So it can be something like, hey, forever, please monitor my IT infrastructure and take care of any cybersecurity alerts. So that's a mission with no end. Or it can be a very much more transactional, like, hey, please analyze this and do that, right, in a finite amount of time and with a beginning and an end. So basically, to answer your question, a multi-agent system is a system with multiple agents collaborating together to achieve a task or a mission. And then there are different ways to build or to design them, of course, right? So some multi-agent system can be more or less self-forming or more or less deterministically pre-wired, if you want, in a certain way. So we can talk about this, right? Of course, different types of multi-agent systems. But that's the whole genesis of why multi-agents we think is going to be important.
Another interesting sub-problem, or maybe a superset of the problem of multi-agent systems, is determining what are the parameters, but also what are the boundaries, where most of the time, at least in the readings that I've done and the conversations that I've done, the general case is that when somebody is talking about a multi-agent system, it is within the constraints of a single team or a single organization or a very specific problem set, where they say, I have maybe my supervising agent that does the routing to determine how do I decompose this problem into subtasks so that I can then send those to more specialized agents to actually perform those specific actions with their more constrained set of tools. But as these systems become more sophisticated, more trusted, then they will naturally start to grow in terms of capabilities and extent. And in particular, with the introduction of things like the A2A protocol, where we say, hey, we want these agents to be able to talk to each other in a dynamic way, then we start to go beyond the boundaries of a single team or an organization. And I'm wondering, as we start to think about how do we actually allow inter-organizational and even maybe interpersonal multi-agent systems to communicate and execute on particular actions, what are some of the new challenges that come about in terms of the trust building communication parameters and the coordination of which agents should be doing which tasks. And maybe we don't necessarily need to have a different implementation of these different agents that are doing similar tasks. Maybe there's just one canonical agent that you just spin up an instance of to be able to do a particular thing.
Yeah, so that's a great point and set of questions. I'll try to unpack it on a few dimensions because there is a lot in what you've said, and you're absolutely right. This, I think you've summarized well. The all the excitement and all the complexity. Because we know the potential is enormous, but then there's so many ways to attack this and to do these multi-agent systems. So the first thing is, so you took the example of a supervisor agent, which would decompose task and then call. So that's already a fairly sophisticated type of agents. There are even simpler agents or simpler mass multi-agents system structure that we can think about. I like to do this parallel. A lot of us in the industry have been through the cloud revolution moment, and we've seen the cloud native architecture and the cloud native technologies emerging on top of the more classic IT we had before. And at the time, I remember we talked about the lift and shift. So people, some folks were like, "Oh, I took my virtual machine and that's it. I put it on a YAS. I put it on one of the platform, and hurrah, that's it. I'm in the cloud." and at that time we're like, well, there is more to what actually it means to have a cloud native architecture, right? And the way you actually rethink everything around microservices and elasticity and high availability. So I think something similar is going to happen with agentic. And so the similar of lift and shift is actually you take in an enterprise a well-known, approved, certified process, which can be even like a very linear process, do A, B, C, D. We have this type of process all over companies, like, for customer relationship or for I don't know, in HR or in finance, very, very deterministic and very rigid process. And by the way, most of the time, if you have people implementing these, humans implementing this process, it's not really collaboration. It's more like transactional. It's like, please do this. Oh, you're next in the process. And so we see players starting there for their multi-agent system. Like, I'm going to lift and shift an existing process. So I know that it has a beginning and an end. I know that two agents are not going to go in infinite loop arguing with each other or whatever. I know that the process exists, the call graph, the logic exists. I'm just going to port it in an agentic way, and I'm going to select agents for the specific task, and voila, that's it. I'm already doing a multi-agent system. And what I said sounds fairly straightforward and simple, but you already have a lot of productivity gain attached to this, right? Doing this type of stuff, especially if the agents are very specialized and able of executing these things with a good level of reliability. And so this is, I would say, on one side of the spectrum, like very rigid, but yet lift and shift predefined type of mass structure. On the other side, you have the full self-forming. And the full self-forming could be literally like one supervisor agent or one root agent starting to decompose the problem and starting to dynamically decide, reason about the problem, create a plan. It could look like, even like a Kanban, and then start to look at the different types of agents and which are needed, and then start to literally search for these agents in real time, in runtime, right? And try to hire the best agents for the job and try to build a project which has, hopefully, will converge to fulfill the goal or the mission. And this is where obviously you have a lot of complexity, because how do you make sure that your mass is going to converge? How do you evaluate, how good it is? How do you discover agents in real time and hire them? We are not there yet, although we think we should get there, right? In a very open and interoperable way. And so you have all the spectrum between these two extremes, like the full self-forming and the fully rigid. And one nice sort of in between architecture or design for a mass is maybe you're not going to have a fully predefined call graph, because that's quite rigid and it doesn't allow for more creative way to solve missions. But you can start with a defined set of agents, which is usually how human would do a project in a company. Like it's like, hey, we are going to do project A, whatever, and well, I need a developer, I need a UX designer, I need someone from marketing, I need a product guy, I need someone from finance, whatever it is, right? And so that actually, I think, is a good way to think about, what are the fundamental agentic skills you need. Gather this team of agents and maybe give them a supervisor or give them, a sort of a Scrum agent, which is going to help them work together. But here you have control, at the beginning on, the set of agents which are going to do the mission. So yeah, all of that is possible. We are looking into all of this, and there is a lot of fundamental infrastructure building blocks that we need for this. And you mentioned A2A. I want to say something about A2A and MCP because these are the two protocols that we're probably talking most about today. And for us, when we saw these two protocols coming, we have a large initiative called Agency, which is an open source initiative where we are trying to bring a lot of contribution to the infrastructure for multi-agent system, and we can talk about it a bit later. But in Agency, we had designed an agent-to-agent protocol called ACP. And when we saw A2A and had really good discussion with Google and the rest of the TSC, and we joined TSC today, so we are on the A2A TSC. We were at the A2A summit this week in New York. A lot of activities there. This is the exciting moment where an entire industry is forming. A new layer of the stack is forming. So this is very exciting for all of us. We defaulted for A2A because it's great. We knew we needed something like this, so we dropped our own protocol. We didn't drop the rest of what we are doing, but just we wrapped it around A2A because we were like, okay, that's great. Let's join forces. And A2A for us is important because that's really like a peer-to-peer type of protocol. While MCP is much more suited for context by the name, but for like tool calling. So if you have an agent which needs to call a tool in a very transactional way, like I need this done, thank you, goodbye, see you next time, I need you, MCP is perfect, right? But if you need something which is more like a peer level collaboration, like agents could, collaborate not just as one is a tool for the other, but they can go back and forth and they can, bring information to each other and they can reason together. Then that's why we think, it's very important to understand that we need both MCP and A2A, and they are not equivalent. They're coming from different perspectives, and it's very important to be clear about it.
As we get to a world where we have a number of different agents that are available and we can get to the point where we have that discovery protocol and we can say, okay, this is the task that I need. I'm going to select this agent because it advertises this capability. I'm going to hire it, to use your terminology, for the duration of this task. That brings us into the world of the decentralized system where the current web is the largest and most successful example of such a system, and HTTP is the most ubiquitous protocol, but there are numerous other protocols available. And as we get to a point where we do have the Internet of Agents, what are some of the new concerns that come out of that? Because the web, while it was a well-intentioned project, has also been, it's a double-edged sword where there are a number of security issues and a number of other issues around consolidation and control that come into the picture. And as we get to the point where agents are the primary operators in this interconnected world because of the fact that they're able to sustain much longer communications than an individual human can, and they're able to operate at a much faster rate than a human can, how does that compound the complexity and the issues around trust and security and autonomy?
I love that question, and you have no idea how much we've been talking about exactly what you've mentioned here and the question you asked. This was actually the genesis of it. We looked at, so we had the intuition agent would be important, multi-agent system would be important, and then we started to look at it, step back, and say, okay, what is it that we can really do here? How can we contribute to the community, to the industry? And then we realized that the Internet of Agent was a necessity, right? Not just for us, but for the world. And we came back exactly to what you've mentioned, which is how did the internet started, and the fascinating infrastructure which is now powering the entire digital economy. And then of course later the other waves of innovation, and the structure of the web has and the internet has changed, especially under the with the formation of the large hyperscalers and cloud platforms. And even this is bending, this is a force field across the entire internet, and how information is flowing, with these big platforms. But one thing we told ourselves is it was important to go back to the roots of the internet, and we had a bit of a birthright to help here, and to be vocal, and to share the vision that we need the Internet of Agents to be open and interoperable. We need any player to be able to build an agent and to announce this agent to the rest of the world, without having to comply to the particular regulation of, you're not on our platform, you're not visible, you don't exist, you can't be advertised, you can't be seen by others. So the announce and discovery problem was really like the first fundamental problem that we thought about. And this is an entire pillar of this agency project, and the Linux Foundation project now that we have started with the community. And so the internet is great, but the internet is amazing because it's distributed and vastly decentralized. And so we started to wonder, what is the equivalent of DNS? And the DNS, by the way, mind you, is vastly distributed, but not fully decentralized. There is an entity called ICANN who's looking after this. So, and a few things happened since, like in particular Web3 and all the blockchain, and decentralized technologies. And we're like, there must be a way to do something smarter. And so this is exciting, because this is like many years later, can we, as we see a new form of internet about to emerge, can we fix some of the problem from the initial internet? And so there's multiple axes. One is, we are all more or less familiar with the 7-layer OSI communication, and you mentioned HTTP, which is right in the middle here. But we see almost like additional layers emerging, like layer 7, which is the application level, is not enough. We need to be more specific. So of course it can contain anything, all the content, but it's actually very useful, we think, to explicitly mention the syntactic layer and the semantic layer. And especially for agents, it's becoming really important, because the syntactic layer, which you can picture, emerge on top of the application layer, is really like the grammar and the vocabulary that you're going to use to, do we speak the same language, or do we have the same grammar to even understand each other, right? And A2A for us is definitely in this, or MCP is definitely at this level, trying to solve the syntactic communication problem between agents. On top of this, we have the semantic, which is really like the substance, the meaning of what is the knowledge and the information, which is actually exchange between agents. So that's just to pick up on your, putting things in perspective with the beginning of the internet. We think that this agentic revolution is so fundamental that it might actually introduce new fundamental layers in the communication stack, syntactic and semantic. And the second axis is about, as I said, discovery and announce and discover. And here we are actually pushing a directory, a mechanism which is completely distributed and decentralized. And we think it's important. So basically, what we are pushing and what we are, this is still the beginning. So we are in the process of convincing the industry that this is a good idea. Of course, this has to be completely open, completely interoperable. We're pushing a protocol and, mind you, a particular module or a node which any player can deploy. So any player can deploy a directory node. And this node gives you the ability to manage your agentic assets and advertise to the rest of the nodes. So that's literally a decentralized network. And we think this is a great opportunity to push the fundamental decentralized nature of this new internet a bit further than the original internet. And we think that, so few things important to mention here, and I won't be too long. The first one is, this is using technologies like OCI, which is there was no need to reinvent the way we are packaging information or storing information, for instance, about containers. So this is an extension of the cloud native OCI for agentic. We have created a format called OESF. OESF stands for Open Agentic Schema Framework. And the word which is important here is the F. It's a framework. So it's a framework to describe any metadata for any agent. And then you're going to tell me, okay, but then Guillaume, this is going to be opinionated and it's going to be like a particular way to describe an agent. And maybe folks want to do it differently. And so that's where it's a framework. So it's fully extensible. Like we were doing only our own protocol. Now we fully included MCP and A2A. We're working with Oracle on something that's called agent spec that they have, which we are going to integrate as well. And I say we, it's not us, it's the community, right? So we have a framework which is fully extensible, which is here for the greater good of everyone, which we can keep extending to enrich how we describe agents. And there is a lot to say about agents. Not only what they do, but also how you deploy them, or if they are already deployed for you, where you find them, aspects of how you communicate, how you collaborate. You can attach security artifacts, you can attach observability and evaluation artifacts. So there is a lot here. And we think it's a really great idea to approach the discover and announce problem through a federation like this. And yes, a lot of inspiration from the Web3 as well here. And the thing on which we are still working, and it's an open problem, is how we fuse this with identity, right? Because as you discover the agent card of a given agent, you also want to. It's easy. We have already solutions to fully sign and verify that a particular card is legitimate, has not been tampered, and has been originated by who it says has originated it. But how you can link it with the agent identity is a more complex problem, because with agents you have many identities to take into account. And as you said, yes, agents are interesting animals because they have indeed attributes of humans, but they also have attributes of workloads. So they sometimes behave like a human or like a user in the stack, but they also operate at scale and speed of machines. So agentic identity, in addition to the discovery, is the second pillar on which we are working. We are not the only one. There is a lot of work to be done here, and that's also opening a lot of interesting problems to solve at the infrastructure level.
Another interesting and potentially challenging piece is in this world where there are agents that are available and maybe you want to make use of them for a particular component of a given task. And so one of the thorniest challenges that we're tackling right now, just with generative AI as a broad capability, is the question of cost predictability, because one workload, depending on how much text you send or how much information you're sending or how much reasoning is required, can have a highly variable cost associated with it. So it's very unpredictable in terms of what you're actually going to need to invest to achieve a particular outcome. And so if you're now in a world where I have an overall objective and I'm going to hand that off to maybe a coordinator agent, it is going to farm out some of those pieces to other agents that are controlled by other entities, because maybe I need to use your booking agent to reserve my flight, and then a different agent to reserve my hotel, and a different one to plan my dinner reservations if I just want to, say, make me a vacation plan. Then there's also that question of cost for the bookings. That is a separate issue, but more specifically for the cost of actually executing those agentic workloads by an agentic identity or entity that is controlled by a different system than yours. And so then how do you figure out how payment gets allocated or transferred through those interactions? Because, if I'm somebody who runs a particular agent, I don't want to do that work for free if I don't have some guarantee of remuneration. And I'm just wondering how that is being considered or addressed in this new and potentially scary world.
Yeah, no, that's great, because you're hitting on the nail. A lot of issues we see coming with multi-agent system. On one side, they are very attractive solutions because they can autonomously do things that we couldn't do without a lot of humans in the loop before. But on the other side, there's a lot of pretty interesting engineering challenges to solve. So few things. So just to pick up on your remark and question, I'll talk about two aspects of what we are doing. One is identity, I just mentioned. I'll talk a little bit about it, and observability as well. And by the way, there is no surprise here, right? We are Cisco, so who's surprised, as there is a new era unfolding to find us doing connectivity, security, and observability and identity? That's who we are. And so, in a way, we are not really innovating here. We're just translating, what we do in a new world. So the identity piece is interesting because let me start with observability first. So the scenario that you've depicted is a great scenario where you have actually no idea what's going to happen, right? Like you have no idea what's going to be the cost of all these agents collaborating together. Probably these agents are hosted in different platforms. They have been designed by different vendors. The only thing is that you have put this multi-agent application in the middle, which is going to this call graph in the middle, which is going to stimulate and exercise all these agents in order to achieve the mission like build me wonderful holidays. So the first thing we need is we need observability. And so when we talk about observability, identity, connectivity, a lot of folks are like, hey, Guillaume, yeah, but look, I mean, we've been working 15 years building the cloud native stack. So we have everything we need. And by the way, you're Cisco, you have Splunk, you have so many great observability solutions. Problem solved. We can observe these agents are just workloads. So end of the game, right? Let's just observe these workloads. And this is where, as obviously many folks listening, I'm sure, are already there. This is where observing an agent as a workload is useful, because as a workload, it can fail, it can have memory issues, it can have whatever, Kubernetes configuration issues, it can have connectivity issue, and so all the classic observability matters here. But it's also an agentic system. And if you look at the semantic level, then it might be displaying like I'm super healthy from a workload standpoint. All my metrics and all my mails, metrics, logs and everything looks perfectly fine. And I might be going completely nuts and doing nonsense work and not at all helping to converge the mission of the multi-agent system. And so we have been working on extending the OpenTelemetry schema, so literally like the de facto standard. And and again, when I say we, it's us at Outshift, together with colleagues from Splunk and many other big names in the industry, a lot of collaboration with Microsoft here specifically, to extend OpenTelemetry to be relevant for agents and multi-agent systems. So now we can get metrics and we can get traces from agent to agent collaboration. So we're really observing the mass itself, not so much a particular agent, but anything an agent do in the context of a mass. So any tool call, any interaction with another agent, and we can. So of course, at some point you can go and inspect the actual payload, the semantic of what two agents are exchanging. And you can apply a third agent, typically an LLM as a judge, right? Or this type of techniques to determine whether you think that this is going anywhere, this is appropriate, or these two agents are lost in what they do. But in a more deterministic, but this comes with a cost, and this is of course one of the methods. But in a more deterministic way, what you can do as well is you can just observe the behavior of the mass. So in the case of your application, you're probably going to test it a few times before you release it for production. And as you test it, and it's highly recommended to test it and to observe it a little bit, in staging before you release this. You can detect a lot. You can deterministically, so for at a very reasonable cost, determine that you can start to understand the pattern of how this mass is functioning. So, for instance, you can see an agent systematically doing, failing or doing 5 call to the same tool, sort of failing, and then, and so you can realize, okay, so this agent doesn't have the right tool. or you can see two agents systematically going back and forth. You can detect loops, for instance. You can detect infinite loops, right? Which are the nightmare in terms of cost, because then cost explode when two agents starts to. So it's not an exact science yet, but at least we are, like in this case, observability extended to agentic is a very, very minimum and necessary tool that we think is going to help a lot mass developers and engineers to prevent these massive issues around costs, or simply not converging or disappointing the end users. And we're doing a lot of additional work in this direction, some more complex work, but starting with this extended telemetry and observability, even simply, I'll give another example. We talked about the deterministic mass, the mass which are functioning along, a predetermined call graph. But we also talked about the mass which are more self-forming, or the collaboration between agents is emerging. It's actually great to be able to visualize the call graph of how this is working. Even something like this. So we have released, a small SDK, which, it's all OpenTelemetry compliant. So use this one, use another one, doesn't matter. What's important is, to leverage the standard on the OpenTelemetry side. And we have something called the MCE engine, which is really helping to analyze all the traces. And this is a way to actually visualize the call graph. So visualize the actual collaboration which is happening between agents, because this is not something which you systematically know in advance how it's going to go. And then you can detect a lot of patterns like, okay, I see these guys are wasting their times, or these guys are not converging, these guys are going to cost me a fortune. So anyway, all these tools are really trying to help with the problem you outlined. And the other thing I would say, again, trying not to be too long, is identity is another big problem. So I talked about the fundamental problem of identity and the internet. So here we have three identities that we need to reconcile. You have the identity of the agent card. You have the identity of the agent itself, runtime, right, as a workload. And you have the identity of the agent as a business function, I would say. So basically, you need to reconcile these three identities, and they live in different layers of the stack. So that's one, interesting aspect of, cross-layer integration that we are working on. And the other aspect is, so the most interesting identity here is the business identity, because this is where you're going to attach permissions. And this is where using classic human user identity and permission system is falling short. And why? Because a given agent can be working for you at a point in time, and 50 milliseconds later can be working for me with completely different set of permissions and authorization. That's completely new for the stack. The stack is not, like a human user is much more continuous and constant in its, rights and level of permissions. So how do you handle that? Well, simply you need completely new proxies and completely new components in your stack to be able to acknowledge that a given agent can have by default certain level of agency authorization. Like, for instance, the travel agent is okay that the travel agent maybe has access to some travel database and some travel transaction system, and under no way should have access to the HR system, just as an example. So you can do this as a fixed rule when you deploy this in a company or in a multi-company environment. But then there are other aspects which really depends of, this is what we call the TBAC, and actually we should call it T3BAC, because this is about the tasks, the tools, and the transactions. And it really depends. It depends who the agent is working for at a point in time. And it depends also the context of the transaction or the context of the tool that is being called. And one of the problem is with the again, if you use the mechanism for authorizing access to a particular tool in an enterprise like a regular user, like, I don't know, I'll take an example. Like at Cisco, we are using an HR system from a well-known SaaS vendor, right? So anything HR for me, I check my HR status, holidays, book holidays, whatever. I'm going to do this with this SaaS. The level of granularity to authorize access to my profile is literally binary, 0 or 1. Is like, can you access, do you have Guillaume's authorization to enter Workday in this case and, act on behalf of Guillaume or not? And that's a problem, because if I want to use an agent to check my holidays, I want the agent to have only access to this portion of the APIs. I don't want the agent to be able to do other things which I have access to on Workday, which is, for example, fire my entire team, which could be literally like a catastrophic type of agentic derailment. So for all these reasons, we are creating solutions, which again, everything is on agency, to manage this TBAC. So tool, transaction, task level access control with a much higher level of granularity, and at a frequency which is changing way beyond what a regular human user would be needing in the real life. So yeah, I picked up on these two examples because the minute you want to deploy something for real, without observability and without identity and agency access control of a different kind, which has never been developed so far, you cannot handle agents in your stack.
One of the other interesting complexities of this internet of agents is what becomes the role of the human in that regard, where maybe I am the person who is initiating a given request, but at what point do I get brought back into the loop? And how do you do that without getting to the point of notification exhaustion, where I don't want to keep getting asked these things? I'm just going to give up and say, just do whatever you want. Don't ask me anymore. I give up.
Yeah, that's a huge problem, and yeah, so there's quite a lot to say here as well. So we need human in the loop, right? The way I'll try to make it short. So a few things. So first of all, we think that the way you designed a multi-agent system is going to lead to a new era for the UX team as well, right? So our UX team is thinking a lot about what it means to design a user-friendly agentic system. One of the big problem is that if you don't really think about it, and I think a lot of the well-known players like ChatGPT, OpenAI, Claude, Anthropic, all these guys are doing a fairly good job of keeping the human in the loop, which doesn't necessarily mean that I go back to you and I keep asking you questions, but at least I'm letting you know what the hell is going on, right? So typically, decomposing the thinking, letting you know I'm doing this, I'm doing that, or finding a way to, like splitting the screen, like here is the chat on the other side of the screen, the piece of code I'm writing for you, or the visualization or the HTML page I'm generating for you. I give you a sort of a way to visualize this. So we're thinking a lot about it. The thing is that the state of the art today is mono agent. When you interact with Cloud Desktop or with ChatGPT, just to take two very obvious examples, well-known examples, you actually interact with one agent, and this agent is telling you, hey, I'm doing this, I'm doing that, and of course the streaming is one of the most basic and fundamental aspect of. I don't wait 5 minutes to, I start telling you where I am, and I start streaming back the response. And it's like the very early days of the internet when we were downloading on very low bitrate networks, with the old modems, and you could see the image being loaded progressively, right? And it was just keeping us busy looking at the image, being, displayed progressively. And that was keeping us, patient in a way. So that streaming is exactly the same mechanism. But what has not been done yet, and this is where we are heading and working on in terms of user interface, is doing the same for multi-agent systems. So you're actually, obviously, these companies have multi-agent systems hidden behind their big agent, right? But it's implicit, it's not explicit, it's hidden, right? For good reasons, for simplicity of usage. we think that in an enterprise context, when you literally have a team of agents teaming up to resolve a task, it will be important to give visibility to the actual work of the team of agents. Think about it. You are a human and you work, like you, Tobias, me, and two other folks who are working on a project. We have a sense of, what's going on, and we have notes on our latest meeting, and we have a shared repository with our assets, and I know what you're doing, you know what I'm doing, this is the whole Scrum Agile. We keep each other informed about how we are progressing, we collaborate, we go back and think. So it's going to be probably a good idea to, as we keep putting the human in the loop, to give visibility on the fact that it's not just one big magical solution, but you actually have multiple agents with specialized functions working in the background, and so let give visibility on this, which is something really new we haven't seen yet, and I think it's going to be very cool to make progress on this. And then there is the other problem, which is, like I talked about the TBAC. So the TBAC there is a perfect way to solve the TBAC problem. Before agent does any call to any tool, stop and put a human in the loop. Is this okay for this agent to call this tool or to have access to this data? And so the name of the game is, how can we securely reduce as much as possible this number of interactions, right? So there is no silver bullet. It's a sum of many things. It's a sum of some of the techniques I've explained, which is like having fine-grained policies which are established a priori, so before the agent, like at the start of the setting up the agentic context. And some of these will require AI. So we're going to have what we call special agents. So we're going to have, as part of this clique of agents working together, one agent is going to be specialized in actually learning over time and, being the guy in charge of going back to the human and asking questions. So if as an agent you need to use a tool and you don't have permission and you need to ask permission, or maybe you go and talk to me, I'm another agent, my only job is authorizations. And as the TBAC agent, I'm going to improve over time and grow a confidence for where I can grant you automatically access with the minimum set of APIs that you need. And when I have a doubt and I need to go back and ask the human, and as the human is giving the answer, this is obviously wonderful feedback, which I can integrate in my in the training for improving, or fine-tuning my model. So yeah, these things are much needed. The concept of special agent is very interesting, because when you think about it, there are agents which are doing the primary tasks for a mass, and we think there is going to be a set of agents, and we're working on those, of course, and we're probably not the only one, a set of agents which are going to be utility agents or sort of infrastructure agents, or IT organization agents, which will be there for access, TBAC, control. We're thinking about security agents. Of course, an observability agent can do a lot of things, because you can send back all the telemetry and do the analysis in the cloud. But a lot of customers also want to know that things can stay local. And so having a local observability agent, which can raise alerts or give you some visualization of what is going on locally and take decisions, is also a really good idea.
Well, if you have a special agent focused on security, you're obviously going to have to name it 007.
Yeah. Don't get me started with code names. Yeah, that's true. I mean, yeah. Well, we have Sherlock's, we have Poirot, we have 007, we have all these, funny special agent names, it's a lot of fun. But yes, exactly right. By the way, the security agent is quite a challenging one. How do you know? Because it's not a class. At Cisco and many other companies, we have so many solutions for classic infrastructure security. Here, this is more about. I'm not kidding. This is really about getting into the mind of agents, and checking that things looks coherent and consistent, and checking that an agent is not trying to hide a special mental state to the others, or trying to say something and do something else, because and it could be an agent or it could be a clique of agents. Anyway, so the security agent is and of course needs to also collaborate closely with the observability agent. It's just fascinating, to talk about this world where we have these new colleagues, these agents, which of course are not human but have some attributes and will join the team and work for us. That's it's very exciting. There's still a few years of work ahead of us, but this is progressing fast. And yeah, we think that we are certainly working on a lot of these problems today, and not just at the infrastructure level, and again, agency and all the infrastructure code and solution we are trying to share, but also we are learning from examples. We are developing examples for ourselves to eat our own dog food and convince ourselves that multi-agent systems can do a lot of amazing things, and they are bringing also new problems that we need to solve.
And as you have been working in this space and helping to explore the boundaries and frontiers of this strange new world that we're in, what are some of the most interesting or innovative or unexpected ways that you've seen either the agency framework and set of utilities or just the overall principles of multi-agent systems applied?
Yeah, so that's I'll be humble here because I think we are at the beginning of this I don't know, multi-year, maybe multi-decade era. But yeah, so what we've done is, so this is a chicken and egg problem. Like, we wanted to help and we wanted to come with agency and with a lot of this foundational software to help. But at the same time, so now it's easier because we have formed a large community. So we have a lot of, contributors. We probably still play a key role on agency, but this is not in our hands anymore. This is, has been donated to Linux Foundation, and it's really in the hand of the community. So we are getting a much more 360-degree feedback, and views from all the players and sharing their feedback as well. But when we started at the beginning, back of 2023, beginning of 2024, and this was all still internal stuff, we needed to learn by doing. And so we started with a few experiments. So some experiments went nowhere, but a few experiments have been actually going super well, and some are being now will being part of the mainstream Cisco roadmap for bringing new features. So we looked a lot at IT ops and AI ops and SecOps and NetOps. So basically anything which is around the supervision of a complex IT system and complex IT stack. So basically we, as you would expect, we're trying to apply mass to our own vertical, our own domain, which is IT. And so a few things. So we have I'll give you three quick examples. The first one, and these are three examples where we had amazing results. So massive productivity and time saving and gain, with agentic. So the first example is network configuration validation. When you have a large enterprise or even bigger, like a large service provider, a large telco, validating a new network configuration is not a small deal. It's actually a make or break. If your new configuration that you're going to deploy to enable the business, to enable new features, to enable new extension of your activities is bogus, you will simply immediately stop your business, right? And so usually customers are spending weeks and weeks to validate these configurations. And with, in this case, a fairly deterministic workflow, but really good and specialized agents, we are bringing this back from weeks to a few hours of getting a really high level of confidence that this configuration can go ahead and be deployed. So that's very exciting, and of course something which you can imagine Cisco is pushing into a number of products coming up soon. Another use case is the root cause analysis. And here we really took an approach of how do I root cause, suddenly my application is not working anymore, or my application performance is degrading. What the hell is happening? And the problem could be internet, the problem could be network, problem could be hardware, server, storage, could be Kubernetes configuration, could be the new configuration that the application team just rolled out. So troubleshooting this can be really complex. And same, we've created a bunch of agents which are literally reasoning like humans and looking at all the graph of possibilities for where the problem could be and pruning it, as they pull telemetry from the system. So you have an agent specializing in, forming a hypothesis, an agent specializing in, retrieving the telemetry, an agent specializing in analyzing, and an agent specializing in, wrapping it together and deciding if we need another cycle of reasoning. And this has been spectacular. We have seen working on real incident telemetry from our customers. We are bringing back things like you need a team of 5 of your best experts from all across the world, in the same virtual room for 4 days to find the problem, to 15 minutes and less than 600 LLM inference of, in this case, a not particularly massive LLM. So again, the productivity gain are wonderful. And there is a third example. I need to mention this project. It's an open. So these projects are closed source because they are close to our business product. But there is a third project which we have fully open sourced with the community called CAPE, which is the community AI platform engineer. And this is really like an agentic engineering platform. So taking care of your Kubernetes deployments, taking care of your... So this came from actually the necessity in my team to scale, with no additional budget for the platform team. And so at some point I told to Asit, who's our director of platform engineering at Outshift, I said, hey man, we don't have more resources, but maybe, we start using Mass to actually automatically solve much more of the tickets of our own team. And so that you guys can spend more time actually, like, instead of working on tickets, why don't you work on an agentic system to solve these tickets? The idea was that simple, and it has worked beyond what we could have hoped. So Cape is fully open sourced. We've worked this with the Canoe community, which is really like the DevOps community, with many players from AWS to Adobe and others. It's working well. It's in my team. We have connected it to more than 40 tools, and we've made it like fully integrated into our backstage. So like any developer in the team in the morning, would come up and have Cape ready to help and assist. And of course, it's not 100%. It's maybe 30-40% of the tickets which can be completely automated. But the characteristic of all the use case I've just mentioned is none of them requires 100%. So if you try to do the autopilot for a car, where even 99.9 is not good enough, it's very, very difficult with agentic. But if you have a use case where if agents are doing a really good job 90% of the time, this is already massive productivity gain, then you can go so far with agentic today. And so that's why we are so hopeful that more of these use cases, at least for our vertical, and we know for others, are going to be very significant. And that's basically what motivates us to keep investing on, building this infrastructure for multi-agent systems.
Are there any other aspects of the work that you're doing on the agency framework and the work that you're doing at Outshift, or just this overall topic of multi-agent systems and the Internet of Agents that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered a lot. I think just to wrap, yes. So I encourage folks to go and check agency.org. They will find all the reference to the material I talked about. Cape is great because that's again a beautiful multi-agent system, open source example, fully open source. So Cape is something you can find as well in the open and learn from. In agency, we have, we took inspiration from the sock shop, and the Kubernetes, right? So we also have an application called the Coffee Agency, which is basically a bit of a toy application, but helps you understand exactly, the different components of agency and how it works. And one of the nice things that this little application is illustrating is, very, very ironically, we talked about identity, discovery, observability. We didn't talk about connectivity, but we have a piece of technology which we think is really important called Slim, which is fully, compatible. I mean, basically, we have Slim supports A2A, MCP. It's gRPC based. It's super high performance. And so this little toy application, the Coffee Agency, shows how you can use Slim in different configuration to help with agent-to-agent, agent-to-tool communication in an optimal way. One thing I maybe would say to conclude is Slim has been designed primarily to do a much better job than just A2A in isolation or any other protocols to deal with agentic group-based collaboration. When it's not just point-to-point, agent-to-agent, but it's a team of agents working together. And we think this is really important and inspiring just to look at how human works. We work as teams, and we keep using either video call tools or we meet in person. And we think that agents, most of the mass collaboration will be group-based, and Slim is a very, very unique and highly differentiated technology for that. We have a paper that we did with our good friends at MIT, the folks doing the Nanda project, which is another, we share so much of the vision for the Internet of Agents with these guys. We have integration on the directory side that we are going to share very soon. So their directory, our directory, kind of interoperating. And we have a paper showing how Slim, so as a communication messaging, underlying syntactic and semantic level, A2A in this case, is scaling much better and is offering like completely different order of magnitude, better scalability for agentic group-based communication. And we think it's going to be the primary form of communication between agents in the future for multi-agent systems. So yeah, just wanted to highlight this because I didn't make full justice to it, but it's probably actually one of the most solid technology we have brought to the table so far.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And I appreciate all of the time and effort you're putting into helping to explore this strange new world and start to define some of those frontiers. So thank you again for all of that. And I hope you enjoy the rest of your day.
Thank you, Tobias. That was a great discussion.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.